Okay, here's the problem solving video for problem 250. Says find RAB, and we're going to be utilizing the problem solving strategy on page 43 of the text, which says when trying to determine the equivalent resistance at a pair of terminals of a network composed of interconnections of numerous resistors, it is recommended that analysis begin at the end of the network opposite the terminals. Two or more resistors are combined to form a single resistor, then simplify the network by reducing the number of components as the analysis continues in a steady progression toward the terminals. And we basically have resistors in series and resistors in parallel. So we're going to use that strategy. We're going to start over at the right hand side and work back to the input terminals, doing series and parallel combinations. And if we start over at this terminal, we'll see, for instance, that those three resistors are in series. Okay, and the parallel combination, the series combination will be 6 kiloohms. So let's redraw the circuit showing that connection. Okay, so our resulting circuit will look as shown. So we combined the three 2 kiloohm resistors in series. So now we have two 6 kiloohm resistors in the circuit. Okay, so now if we note, these two are in parallel. Okay, and we note if we do the product over the sum, we have 6K times 6K over 6K plus 6K, and that parallel combination is 3 kiloohms. So now let's redraw the circuit, substituting a 3 kilohm resistor for those two resistors. Okay, so now our circuit looks like this one. So now we're just redrawing it to show the new combination. Okay, so now these two resistors are in series. So if we combine those in series, we will get a single 6 kilohm resistor. So now let's redraw the circuit showing that combination. So again, here are the terminals A and B. Here's RAB. Okay, so there's our resulting circuit. Now if we notice, these two resistors are in parallel. And you might say, well, why isn't that in parallel with the 4 kiloohm? That's because the 8 kiloohm circuit is sitting here, and it prevents the 4K from being in parallel with those two. If this 8K were not in the circuit, then we would have these two still in parallel. Okay, and so we wouldn't even be able to get it in parallel with this. So these two are in parallel. They're not in parallel with this one because of the 8K. So the resulting combination is 12K times 6K over 12K plus 6K to give us 4 kiloohms. So again, that 4 kilohm is not in parallel with the 4 down here because of that 8 kilohm resistor. So now let's again redraw the circuit with that combination. So we're steadily working toward the input terminals. Okay, so now here's our resulting circuit. Now, these two resistors are in series. Okay, they're not in parallel again because of this 8K. If you notice, if we had a current flow, the same current would flow through those two resistors. So, two 4Ks in series is going to be an 8K. So our resulting circuit then would be this. So now again, notice we started over at the right. We're combining resistors in series and parallel. We're working our way to the input. Now, these two are in parallel. And in fact, since they have the same value, the resulting parallel combination is 4 kiloohms. So now let's redraw the circuit one more time. And notice now we've reduced the circuit down really to 3 resistors. And if we note, those 3 resistors are in series. So RAB then is 4 kiloohms plus 4 kiloohms plus 4 kiloohms to give us 12 kiloohms for that resistance. So we started at the right hand side and worked back toward the source or the input terminal.